Hello, another video for today. This one probably falls into the I don't want to share all the code category. Talk a little bit more about why later. There's nothing really to shoot at yet, but the basic menu implementation is here. This is a weapon testing mode, so you can change to different guns, try out different attachments, and see which ones you like. I think there probably been a few test ranges or gun tryout portal experiences out now, but I just wanted to share this one that I've been working on. It's pretty basic. It doesn't run very well. It doesn't look very good, but it is functional. So hopping in game here, let's open the menu up. You can see it takes a second to kind of render everything, show you why later. And then as it opens up, you can see there's a close button up here. There's a different weapon categories you can select between: carbines, DMR, LMG, all that. And then you can go in and click on an individual weapon, and it'll just swap to that one as you click it. And then this row down here, the third row, is where you can select different attachment categories. So if you want to look at looking at sights right now, so let's look at barrels. There are so many barrels, I'm not sure which one I can actually click on for this weapon. Let's go to ammo. Needs to finish rendering before it lets me click over. There it goes. And then what can this take? It can take hollow points probably. So now it's probably got hollow points equipped, but you can't actually see that down there, but you can see the weapon re-equipping. And then we close the menu. And then to open the menu, you just jump. There's the menu. I'm also going to show this here. Kind of the reason I wanted to show this in the first place anyways, something you can actually see. So here's a flashlight. That didn't work. Maybe a laser. Okay, this one can take a green laser, blue laser, take a red laser, and you can see it swapping between all those and then just closing the menu out. You can't see that on the video. If you can't, here's the red laser coming out of the gun. Very cool. So now on to the implementation. For this experience, there's no particular map requirement or spatial JSON needed. Script only on this one. Starting at the top, this is one of the event handlers ongoing player. This is called every single tick, once per player per tick. There's a state object, and it's checking if the current object ID is in that state object. So that's tracking live players. This is just something you have to do in the engine. Just checking is player valid, and checking if they're alive isn't really enough to prevent errors when you call subsequent functions on a particular player. If you want to make sure that a player object is valid, one of the best ways to do it is just by tracking who's currently alive by player ID. Then it checks if the player is jumping. If they are, it enables the UI input mode and renders the menu. So that's how the jump to open menu works. Then there's the on-player leave game handler here. It's destroying the UI for that player and then also deleting them from the state map, so it's not going to track this player anymore. On-player deployed, that's when a player spawns. It renders the menu. So as I mentioned earlier, the menu opens when you jump, but it also opens for the first time when the player just deploys. And then it locks the user into the UI input mode so they can no longer move around, but they will be able to click on things. And then it gets the player state, gets the state object for that player, and says that they are alive. And then when a player dies with onPlayer died, it doesn't delete their instance. It just sets their alive flag to false. Then there's the UI button event handler. This just calls into the UI class to handle routing that event to the right function handlers. Got the interfaces here. Dragon's callback is the type for button click callbacks. And then the player data interface, that's what that state object holds. It's got the alive Boolean, and then for each player, it tracks what their currently selected weapon, what's their currently selected weapon category, their current attachment category they're looking at, and all the attachments they currently have selected in a map, keyed by category. So in the player state class, there's the core state map. This is player ID to player data, and there's a get state function. This is just going to look up in the map a particular player's ID. If that player ID exists, then there's a state object for it. Otherwise, it needs to initialize that state object with default values, store it, and then in either case, it returns either the created or retrieved value. Pretty basic. And then there's the give weapon function. This one handles taking the player data configuration for that player and creating what's called a weapon package. So to give a weapon to a player in the game, what you first need to do is create a weapon package with create new weapon package. And then it iterates through the selected attachments and adds each one to that package with add attachment to weapon package. And then finally calls add equipment with the player, the weapon, and the weapon package. So if you're looking at this definition here where it says mod.weapons, these are enums from the library. This is what the developers have exported for us to interact with. This is the official portal API. There's this weapons object, which has all of the currently defined weapons in the game, and there's weapon attachments, which has all the attachments. The currently selected weapon is stored as a string, and then that string is used as a key to look up the actual enum value. So it's doing mod.weapons, player selected weapon as key of type of mod weapons. This way, there's no need to maintain a separate mapping of some object to weapon, just use the native data directly. Going down to the actual UI component now, I wouldn't necessarily recommend anyone else build UI components quite this way. There's something called parse UI, which has been supplied along with Portal in modlib. You can get it through the modlib dependency, and when you're building Portal experiences, you can get it through the modlib dependency when you're building Portal experiences. And someone out there has built a web tool to just let you kind of WYSIWYG drag boxes around, create a UI that way, and then export a JSON definition from that you can just plop into your own experience. This was just kind of me testing stuff out, so I didn't want to use that in this case, but I recommend that you do. The code here defines how tall the buttons are, how wide the buttons are, and how many items per row. There's 12 items per row, so this should take up a 16:9 screen with squares, rectangles. And then there's a registry, which is holding the UI widget names as strings, so it can track what's been created. And there's a callback registry, which maps player IDs to maps of widget names to callbacks. And this is the render function. This will be called for the player anytime the UI needs to update. So when they first spawn in, when they jump, after they change weapon categories, or after they change attachment categories. Here it's generating a unique ID for the UI widget with this root container name helper. Within the engine, one of the ways that you can look up an actual widget component to interact with is by asking for it by name. Name would be analogous, like in HTML, to ID in a browser context. So you can query by that unique string. Here it's taking the player ID and concatenating it to get a unique string for that player, just triguns plus the player ID. Then here it's creating the root container object with this get or create UI widget helper function. So if you're not too familiar with UI stuff, this is basically just a big rectangle that everything else fits inside of. You position that rectangle relative to the screen with add UI container. Here it's using the center of the screen as the anchor, and then it's just sending in vectors which define the sides of that bounding rectangle, the width and height calculated earlier. You can tell it only needs 2 of the fields because it's a 2D UI component. Anyways, the container name gets added to the registry so it can track what widgets have been created. Then it's setting the background color for the UI widget to a gray color at half transparency, fills it with just a solid color to make sure it's visible. Here we're creating rows. This is the row item interface. It's just the name and a callback. The first button that gets added is close. This one just turns off the UI input mode and then calls destroy on the container that was created earlier. You could just set that to set the container to invisible, I believe, and that would be much more efficient because you wouldn't be recreating it every time you needed it. Then we're getting player data state. Here it's getting the categories for weapons. So this is kind of one of the fun things here. Instead of hard coding lists of weapons into the code, it's just taking the keys from mod.weapons enum with object.keys, then iterating over those. It splits each key by underscore and takes the first part, so like assault rifle from assault rifle AK-47. And then it's putting them in a set, so it's going to be unique, a unique set of names, of prefixes. What it's going to do is go over all the weapons and try to add the category like 8 times for all these different assault rifles, but it'll only end up with 1 instance for each category. So then there's unique weapon categories. And then for each category, it creates a selector button. The callback destroys the current UI, updates the selected category in the player data, and re-renders. That's why it's slow. It's completely destroying and recreating everything. Here it's setting up the attachment category selectors in a very similar way, just taking the beginning prefix of the attachment enums with that split by underscore, which is going to be something like barrel, ammo, sight, optic. And then it's creating the buttons for those attachment categories with the same pattern. Then it figures out which weapon category is selected. If nothing's selected yet, it just grabs the first one from the set. Same thing for attachment category. Now getting down into the actual weapons, it iterates over all the weapons, checks if the key is a string, and then checks if that string starts with the currently selected category. There's only one category selected at a time, so the player either starts out with assault rifle selected, or if the player has selected carbines, that's the only category of weapons that's going to be added to the display. So for the display name, it substrings off the category prefix. So assault rifle AK-47 becomes just AK-47. And then when they click a weapon button, it gets the selected weapon and player data and calls give weapon. Pretty simple. Then it adds the weapon row to the rows array, then adds the attachment category selectors. Then it does the same thing for attachments, goes over the weapon attachments enum, checks that it's getting a string key back, and then sees if that starts with the currently selected attachment category. So it'll create a row item for that attachment. The attachment callback is a bit different. It checks if this attachment is already selected for this category. If it is, it deletes it from the map to unequip it. If it's not, it sets it in the map. Then it calls give weapon to re-equip the weapon with the new attachments. So attachments can toggle on and off. And then it actually renders all these rows. Iterates through and makes sure each row starts at the beginning of a new row by checking if the button ID is divisible by the number of items in a row. And then for each item in the row, it calculates which row and column it is in, creates a position vector, and creates a button. Then we use this getter create widget helper again, call add UI button with the position and size, register a callback for when it's clicked, set the background color, make it visible, and set the container as its parent. And then we render the text for the button, and this is the spot that's a little funky. So we split the name into individual characters, and for each character, we create a separate text widget. This is because the engine doesn't allow us to print out arbitrary screens in the UI, and that's probably for like censorship or just string validation reasons that they want to do on all this code. So here, since I just want to print AK-47 and I don't want to have every single label in my strings.json and have to update that every time there's a patch, we just create a rendered string, which is a string of individual characters being rendered by themselves, and then we manually position each character. So inside of mod.stringkeys, all we need are just the lowercase alphabet characters and then the numeric characters, and then we can render whatever text we want. So I wouldn't really recommend that anyone do that in an experience that they intend to publish. Pretty sure you're just directly violating their EULA or whatever they had you agree to. But it is kind of neat, and I think it's pretty useful here for testing. And then we've got this getter create widget helper again, just checking if a widget with that name already exists in the find UI widget with name. If not, it just calls the initialization function to create it and looks it up again. There's a setup function. It calls that to configure the widget. This pattern lets it avoid creating widgets if they already exist. Then the handle button event function gets called from the event handler. It looks up the widget by name, finds the callback that was registered for it, and calls it. I think you saw earlier how those have the assign weapon and assign attachment code in there. Register callback stores callbacks in the registry map so that it can be looked up later, and then destroy finds the root container and deletes it with delete UI widget, which I believe kills all children as well. But I would probably want to verify that before making something actually published. So that's basically it. Pretty rough, not optimized at all, but functional. Hope that was at least slightly interesting. Once again, if you have anything else that you'd like me to cover, please post a comment down below. Thank you.